Now we're going to see sound waves. Part 2 is about speed of transverse wave in a stretch string. The speed V equals to square root of tension over mu. It is mu, not a meow. The mu is equals to mass per unit length of string, and the L is the length of the string, and the T is the tension in the string. So let us attempt one question related to this formula, which is the tension in a stretch string of length 1.5 meter and mass 9.1 gram is 1.5 kilonewton. If the string vibrates in the fundamental mode and the speed of sound produced is 330 meter per second, determine the wavelength of the sound waves. So the speed is about V equals to square root of T over mu, and the V speed of the stretch string for the fundamental mode is F naught times wavelength, and the mu itself is mass per unit length. Mass in kilogram is 9.1 times 10 to power negative 3 divided by 1.5, because mass is here is gram, convert to kilogram, times 10 to power negative 3 divided by 1.5 will get 6.07 times 10 to power negative 3 kilogram per meter. Now we have a fundamental mode for the stretch string with 2 knots and 1 anti-knot. Between 2 anti-knots is the length of the string, and knot to anti-knot is quarter wavelength. We have 2 portions of knot to anti-knot, 1, 2, so we have to times 2 with this quarter wavelength. You will get length equals to half wavelength, and the lambda is 2L. We can substitute the lambda into this formula and all the possible values accordingly, where tension T is 1.5 kilonewton, so times 10 to power of 3, and the mu is 6.07 times 10 to power of negative 3. You can substitute here with the length 1.5 meter. Hence, the fundamental mode is 165.7 Hertz, or the fundamental frequency is 165.7 Hertz. Simple like a bubble without giving you any trouble. Next is about the intensity I of sound is the energy per second incident on a unit area normal to the direction of sound propagation, or intensity is equals to power per unit area. I is the intensity of sound, P is the power of the source, and the A is the area, which is equals to 4 pi r square, area of a sphere of radius r through which the sound energy passes perpendicularly. And 2 important effects for the intensity I is about intensity directly proportional to the amplitude square and inversely proportional to the distance square from the source. The source here is not a chili sauce or tomato sauce, is the source of the sound. Let us try to attempt one question related to this part. It's about a point source produces sound with a power of 200 watt. What is the intensity of sound at a distance of 5 meter and 10 meter from the source? So we can apply the formula of intensity equals to power per unit area for the distance 5 meter, which is I1 equals to P over A. The power is 200. For the distance 5 meter, you're going to get 0.637 watt per meter square, where the area here should be 4 pi r square. And we're going to do the same process for the distance 10 meter, which is I2 equals to power per unit area for the distance 10 meter, where the area is A equals to 4 pi r square. You're going to get 0.159 watt per meter square. And then for the section B, find the ratio of the amplitude of the sound wave at 5 meter to its amplitude at 10 meter. So everyone knows that intensity is directly proportional to amplitude square, where A is amplitude. So mathematically, I1 over A1 square equals to I2 over A2 square. So when you substitute all the values accordingly into this formula, make sure your algebra is good. So you will get the ratio of 2.0. Again, simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.